Alright, so literally all we're doing today is watching this video and then we're going to go over some key notes of this video. Yeah, we're going to have a welder out there, and you'll see what kind it is. But you might not get into it this week because we've got to get the rest of those screws out top of that bus, and we're going to start cutting the bus this week. So we're going to be cutting out whatever dimensions Robbie needs of us this week out of the bus. So, but we will eventually get to welding. It's not like hardcore welding or nothing, but you will need proper PPE and stuff. So, but it'll get into showing you that here in a minute. I'm not sure if we have a welding helmet for everybody out there, but I don't think Robbie would ask y'all to buy a welding helmet for one lap since they're kind of expensive. So I don't know. I think we have a helmet out there for everybody. But this is going to go over all the specifications and stuff of what we would be using out there. And it's only a 15-minute video. It's not hard. And then I've got some keynotes over here for us to go over. And I am going to do a quiz on there, but it's going to be an open video quiz. So I'll upload this video to Canvas. And so if you need to watch it as you go through the quiz, that's fine. But we've got to get some grades in.
Is that the quiz you already posted? Which one's that?
I have no idea. Did I post a quiz for industrial mechanics? I don't think I did, but I might be wrong. I don't think I posted a quiz for industrial.
Yeah, chapter 10, reading questions.
Oh, well, there you have it. That's due next. That's due.
This Friday.
Yeah. Okay. I don't even know what day it is. I'm sorry. My brain's bad. All right. So just watch this 15-minute video. Try to retain some of the knowledge in it, and I've got a Word document we're gonna go back over after this, and that's literally all we got. Okay. This is a very simple class, so just bear with me, okay? But I will say that y'all did a good job on grinding the screws out last week. I know that's not a hard task, but you did a good job. So the same PPE you had last week, bring that this week. So every week for this lab, so you need to wear that same PPE, okay? Because especially when you're welding, you do not want any of those arcs and any of the metal to touch you, because it would hurt, okay? So bring your proper PPE. All right, let's watch the video. Hey man, I'm gonna turn off closed captions. Hang on, let me make sure. I need to turn it up a little bit so y'all can hear it.
Hi, my name is Dan Kling with the Lincoln Electric Weld School. Today we're at Beaumont Scout Reservation in Rock Creek, Ohio. Today we're going to show you how to earn the Welding Merit Badge utilizing flux cord self-shielded welding with the SP140T, the Magnum Pro 100 gun, and we're going to be utilizing the NR211MP electrode. Flux cord self-shielded welding basically is a stick electrode turned inside out on a continuous coil, meaning that there's no external gas required. It gets its shielding gas from the slag covering the molten metal from the atmosphere, and allows us to weld outdoors and over dirtier material than you typically would with GMAW. Before we start welding, we want to make sure we have the proper welding gear for safety. We're going to start off, we've got a Viking auto darkening helmet, I've got a cotton beanie, clear safety glasses, a cotton jacket with leather sleeves, and as I've also got my stick welding and flux cord welding gloves. And also make sure you got long jeans on that aren't tucked into your boots. The other thing we want to make sure is that we're not welding in a damp area. So if you need to put something down, that's fine. And probably the most important is we want to make sure that you keep your head out of the plume for welding and make sure you got the proper ventilation. Okay, now we're going to demonstrate how to set up the SP140T for flux cord self-shielded welding. We're going to open up the door, and we're going to install our coil of wire, our NR211 035. Once we install the coil, we then put on the plastic spacer, followed by the wing nut, just slightly with a little bit of tension. We're going to then straighten out approximately 6 inches of the wire. We're going to feed it into the ingoing guide over top of our 030 045 knurled drive roll into our outgoing guide tube and into the liner into the gun. At that point, we can then close our drive system. We'll set our tension with a little bit of tension on it, just enough to where if we try to block the end of the wire, it'll spin a little bit. Next, we want to make sure that we have the correct polarity of the welding machine. For flux cord cell shielded welding, we want to be on DC electrode negative. So the short lead coming from the drive motor will go to the negative stud. The work lead will be attached to the positive stud. Once we have the machine set up and we have the wire fed out through the contact tip, we then take our material and we use the gauge here underneath the door to determine our thickness. This is showing that we have 10 gauge material. We then look at our 035 211 MP 10 gauge, and it's showing us to use 1.5 on the wire feed speed and D on a voltage setting. Okay, so now we'll take that setting, the 1.5 on the wire feed speed, dial that in, and then we'll take our voltage tap and put it on D. It's very important to get the correct wire feed speed and voltage for the material you're welding. If you have too much wire feed and not enough voltage, you'll get stubbing at the wire. If you don't have enough wire and too much voltage, it'll want to burn back up towards your contact tip. We want to make sure we've got the correct contact tip, the 035 contact tip, and the flux cord self-shielded nozzle. This is going to protect the gas diffuser and the threads while using flux cord. Once you go to GMAW, you then can remove this and put on your gas nozzle for MIG welding. The last part of the setup is our work clamp. You want to make sure our work clamp is set up as close to possible to where you're welding, and make sure that it's got a nice clean setting. You don't want to be putting it over top of any paint or any type of rust. Make sure you got a smooth and ground surface there. Now that we've got our welding machine set up and ready to weld with flux cord self-shielded wire, we want to go over some things for technique. The rule of thumb is slag, you drag. So what that means is if you're right-handed, you're going to go from left to right. With flux cord self-shielded, we will have a slag. The slag comes from the inside flux, and what it's going to do is it's going to clean the weld puddle. The slag is lighter than the molten puddle, and it's going to bring up the impurities and bring them up to the top of the weld so that we have a quality weld. One of the first projects for our welding merit badge is going to be welding your initials. So what we're going to do is we're going to start off by taking a soapstone, and we're going to write our initials on this 1/4 inch plate. So we'll write D, K. Once we've wrote our initials on our plate, we'll go ahead, turn on the welding machine. We've already determined our wire feed speed and voltage. We're now ready to weld. So we'll put down our helmet. You want to make sure you break the wire before you start your next weld. Okay, so we finished welding our initials with the flux cord self-shielded. So you'll notice now I've cleaned the slag off and I've cleaned the spatter off. One thing you'll notice while I was welding is I would break the electrode between welds. That's important with flux cord self-shielded because you get a little bit of buildup of flux on the end of that tip and it won't allow the arc to strike. So be sure to break off a little bit of the electrode in between your welds. The next project that we're going to do for our welding merit badge is we're going to build a pad utilizing the flux cord self-shielded process. So we're going to use a 1/4 inch, basically 3x3 by 1/4 inch plate. We're going to use the same technique by dragging. We're going to break our electrode, and we're going to start by making one weld along the edge and then repeat that, overlapping approximately halfway with each additional weld, being sure to clean in between each pass. There's one pass. Take our chipping hammer, clean the slag off. Brush. Okay, so we've made one pass on there and we've cleaned it. We'll now continue to fill the rest of the pad with weld beads till we complete the whole 3x3 pad. We've finished welding our pad using flux cord self-shielded. Once we finished welding it, we went ahead and cleaned it up, took the slag off, and chipped any spatter that would come off, and then cleaned it up and cleared it so that it'll last and it won't rust. Now, our next step in earning our merit badge for welding is going to be welding a square groove butt weld. We're going to take our two plates, lay them on the table. We've got two, again, we have two square edges. We're going to place them, in this case, tight together, depending on the thickness. Sometimes you may have to put a gap in there, but for this particular thickness, we're okay. We're going to go ahead and tack the plates together. Once we've got the plates tacked, we're going to then run a weld down one side. We're going to flip it over and weld on the other side as well.
But I'm not sure which one y'all will add, but we'll probably have y'all do like something similar like this and then start working on the rest
Okay, once we weld it one side, we'll flip it over. Okay, once we've welded both sides, strip the slag off, wire brush it, and we can move on to our next project. There's 5 major types of joints: butt, lap, corner, T, and edge. We've already done the butt joint. We're now going to move to a T joint. T joint, we're going to lay the one plate down, and then we've got another plate coming in at a 90-degree angle. We're going to first break our wire, and we're going to tack these 2 plates in 2 spots. We'll do one tack here. Another tack. And now we're ready to weld. So again, we're going to slag, we drag. Okay, we finished our T-joint with the flux cord cell shielded.
It's cool enough,
So then go ahead and
but other than that,
clean the slag off. Chipping hammer. And now we're ready to move on to the next project. The last project for our welding merit badge is going to be welding a lap joint with the flux cord self-shielded. So now we're going to take
all right, have we seen him weld enough?
2 plates.
All right. So going over just some key pointers, and this will be on the quiz whenever I make it. I'll probably make it due next week. So let's just go over this. So flux cord self-shielding is a stick electrode turned inside out on a continuous coil. So that's why you're not having to lean in with it like stick, because that coil, that's your metal coil that's just bleeding out of that tip. Okay?
A lot of people just use that. Is it better to use a stick?
Yeah, it's all depending on the setting. Like in industrial settings, like it's probably better to do stick, because you can get into a whole world of welding. Like, I'm not a professional. My husband went to school for welding, and I only know little tidbits like MIG and whatever else. Well, I don't know. Like, I can't tell you everything there is about welding, but I do know in like some applications, you need like heavy duty. You need to be able to weld it really good. Because I mean, you think about like being in a power plant and stuff, like they're welding all of this like stuff together, and if it fails, then you're pretty much dead. You know what I mean? So it could be life or death if it's not a good weld. So there's no external gas required for this welder. But on the other welders, normally you have to have oxygen, and I don't know if there's any other gas required, but you have to have like gas leads to your welder. And it gets its shielding gas from the slag covering, the molten metal from the atmosphere. So this allows you to weld outdoors and over dirtier material. Welding safety gear would be welding helmet, cotton or fire resistant clothing. You don't want to catch on fire. Clear eye protection, because if you're wearing tinted eye protection with your welding helmet, you're literally going to be like walking around in the dark. Welding gloves and jacket, long jeans, and they do not need to be tucked into boots. And I would not wear tennis shoes to weld. Wouldn't do it. Because, like, the arcs and stuff coming off of that welder could burn right through your pair of tennis shoes. Okay? So I'm just telling you, don't wear tennis shoes. Okay? No welding in damp areas. It's a good way to get yourself electrocuted. Proper ventilation, so you don't want to be leaning over that welding in an enclosed room or anywhere that would be trapping those fumes to where it could potentially harm your lungs. So on that welder, you must have the proper polarity, so it needs to be in mode DC electrode negative, and that was in the video. So the short lead goes to negative, and your work lead is attached to the positive stud. So, how can we check the gauge of our material? Do y'all remember?
That thing that you have to do.
That chart. So, whatever gauge it is, it'll tell you exactly the settings it should be on. So, always pay attention to that. Always measure out the gauge of your material. It should. What was I talking about there? It would show us what settings to use. And what happens if you have too much wire feed speed and not enough voltage? You will get stubbing at the wire. And then if you don't have enough wire but too much voltage, it'll burn back up towards contact tip, so you're not going to be welding anything. Okay? And is a work clamp important, and why? We know how important those clamps are. Because if you're holding your material on there, you need to make sure it's secure, just like with that drill press, right? You got to mess around with the drill press, didn't you, Claire? Mm-hmm. So if you didn't have that clamp on there good enough, and you get to drilling that, and that drill hits that metal just right, that is so powerful, it could literally stab into your stomach, like kill you. So that's why work clamps are important. Very important. And that's saying slag you drag if you're right-handed, go from left to right. So you're dragging towards your predominant hand. So if you was left-handed, you would go this way. And make sure you break your wire before starting the next weld because of flux buildup. So in between each pass, you're gonna just bend the tip a little bit, and that's it. That's all you gotta do, just to make sure that there's no buildup there. So this week's kind of a free-for-all, Robbie said, because we got to finish those screws out, and then we're gonna start cutting on the bus, hopefully this week. So whenever y'all get here to do y'all's labs, if you see that there's still screws that need to be done, go ahead and do the grinding like you did last week, as much as you can until you get tired. And then, once we get past that, we'll start cutting on the bus. And then, we'll get to welding. Probably not. I would probably say next week. But we wanted to go ahead and go over it that way. I could put up the quiz, do next week. And that way y'all could do it before we get on the welder. I'll probably make it due Monday, maybe. Next Monday. So, and then just do those questions that I posted for this week. So, that's it. I mean, do y'all have any questions? What do y'all got for me? Looking forward to it.
To weld our initials into like a piece of metal.
Well, that's what I would say that I like, because that could be a good, test grade for y'all, like letting y'all weld on something like that. So I'm not sure what Robbie's done in the past, but I think that would be a cool thing to do. Because the welders, like, it's interesting being able to weld and stuff. Just, it's a good skill to have, just in case you need it in the future. So, I would say yes. I would like for y'all to practice doing something like that before you actually weld on something that's going on the school bus. That way you can get good at it. So we can just use some of that scrap metal we've already been drill pressing and cutting up and stuff like that to let you write your initials, and then we might can do like a T-joint or just something simple, but also something that would help you practice with the welder before you actually touch something that's supposed to go on the school bus.
So did you say he's wanting to put a hole in the top of the school bus?
I think he's wanting to cut out the side of the school. I'm not exactly sure.
From what I understand, the roof is coming off.
Oh, well, you probably know more than I do then. Lab. Okay, so we've done, name off the labs we've done for me.
First there was the chop saw lab. That was lead one. Then I did the drill press. Took out 15 screws with the grinder.
That was lab 2.
That was
So
lab
we're
2.
on lab 3 this week.
Mhm.
And let me see what he has for lab 3 up here, because I don't think it's the same thing. This is different. Not supposed to be that. All right, so I'm just going to go ahead and add this. Lab 3. Okay, so I had this up already. Nope, that's the wrong one. I had another lab put up, I thought, due October 29th. Yeah, that's the wrong one. I'm just going to make a new assignment. So I'm going ahead and creating that assignment. So if y'all was to come tomorrow or Wednesday before I get here, lab 3, and I'm just going to put free for all because it's not a specific lab. So I know y'all have already done the drill press. So I don't know what days y'all are coming to do these labs.
Same.
Okay.
Morning though.
So yeah, because you're normally gone before I get here. So lab 3 is a free for all. So if you go out there and do screws, just take another picture of what you've done.
I'll probably be here when you get here.
That's fine. So whatever you can get done, Claire, that's fine. With, just however many screws you can get out till you get tired. And so I'm just putting, please upload pics of the labs you completed this week. And it'll be worth 100 points. And that will be due the 5th. Yeah, the 5th. And let's see. Allow file uploads and text entry, save and publish. So that's on there. Lab 3 free for all. So just upload whatever you do on there. And Robbie will probably show y'all like what he's talking about cutting out the side, because God forbid me get out there. I would, but I'm saying I don't exactly know what he wants y'all to do. So if y'all do happen to get through with the screws tomorrow, cool. And, but if not, we can get to the cutting next week and the welding. But we still have a whole month left in this class. So we've got plenty of time to play around with stuff, because this class don't end until like, I think the 10th. Let me just tell you to be sure. I think so, yeah.
And
Let me see here. No, don't want that. Academic calendar. Oh, stop this recording.
so is